Hi friends, uh, this is a video for the Calc 3 class looking at the notion of dealing with three-dimensional surfaces. I know that some of my videos tend to run a little bit long, so the thing I'm going to try for this one is actually to just put a timer off to the side, and I'm really going to just try to show you what I can about plotting things in 3 dimensions just in 20 minutes. I'm not going to try to get into anything that's really sophisticated. If you want to see more sophisticated plotting stuff, look at Don's video. He's got this stuff going about something called Plotly that I'm pretty new to, and he'll get you some really good examples just that you can do pretty quickly. You just have to follow along a little bit there. But let me show you what I can do just kind of offhand, all right? So assuming I can get it to work, I'm going to bring up the iPad here and just do a quick screen mirror and just sharing with you the rough off the top of my head things about plotting in 3D here. So the essential notion that you'll have to have in mind is that now, instead of having things where you're plotting in 2 dimensions and having the x coordinate be your domain, now you've got both x and y coordinates. So you have things that are planar in nature. And when you determine a particular point, x, y, then you plug it into your function, whatever that happens to be, and you use a z coordinate, or the height above your xy plane, in order to portray what it is that you're trying to graph there. So you end up getting these surfaces, and depending on what it is you're working with as a formula, you'll get something different. Now, an immediate thing you might ask about is, oh no, my artwork's not all that great. Am I going to be graded down? Or, is that going to be a problem because I just can't draw three-dimensional pictures? No, we are going to totally take care of this sort of thing with technology, all right? So, popping out here real quick, let me see what I've got just on this here. Okay, I've got something called 3D Calculator, which, as you might guess, is a calculator meant for 3D. It's on my iPad. Let's see, if I turn it like this, will it look better? Sure. All right, so the first thing I'm going to graph here is something that's meant to be pretty easy. Y'all, for your algebra classes or something, you would have graphed things like y equals x. So since we have both an x and a y here, I'm going to put in something like x plus y. And then, can I take that keyboard away? I don't know how. Okay, so, oh, there, when I touched it, we could see it. Now you can see your XY plane down there is kind of the fuzzy part. And now our x plus y is this plane that's in, I'd say kind of a slate blue with the mesh grid across it. So if you put in different coefficients for your x and your y, much like you did in an algebra class, you know there the coefficients would give you different slopes for your lines. Here, though, you've got something that's a plane, so changing the x and y is going to change the slope on that, but in the direction of x's or the direction of y's. So if I kind of go over here where you can see the x-axis is the red one, the y-axis is the green one. So as you increase either one of those, because we've got a positive coefficient for both x and y, then we're going to go up. So more about that sort of thing later, but let's try something slightly different. I'm going to just take away the y values and then look at my graph, and you can see that that red axis there, as you go out on that, here, if I can make it look like, okay, so it kind of looks like a line there, but if you can tilt it a little bit, you can see that as you go out on your x-axis, you're increasing. So, but your y-axis doesn't change anything. So for different y values, you've got the exact same x value. And yeah, let me then come in here and have x squared for that. So as you can see with that, now as you go out on the x-axis, you have something that is more of a parabola shape. And since you don't have a y in it, then that means you can translate the parabola in the direction of their y-axis and still have the same figure. So, but we might want to get a little bit more interesting and have a plus y squared there. And when we do that, the shape that we get looks more like what we refer to as a paraboloid. Ooh, I left it with a little momentum and it's just spinning on us there. Okay. So you can get lots of different things coming out. If I make this change and have x squared minus y squared, we have this shape here that's sometimes referred to as a saddle. Okay. And now if I come over here, let's see, where are my functions at? Sine function. If I say sine of x squared plus y squared, you all know that sine should do something that oscillates up and down. But now this x squared plus y squared, if you took a look at x squared plus y squared before and you just had this parabola or this paraboloid going up, it was kind of circling around the origin. So this sine should give, the sine of x squared plus y squared should give us something with kind of circular symmetry to it. And ooh, that doesn't look very good, does it? See how jagged it gets? And that has to do with how the computer samples stuff. But if I zoom in a bit so that we're only seeing a bit of it, then you get something that's pretty smooth. But as I go out, the computer sampling is going to be less smooth just because there's more points to deal with. So that's actually kind of a neat animation to watch happen, isn't it? So, okay. But in any case, the tool that I was working with there is referred to as 3D Calculator. It is from a company, or it's from a utility called GeoGebra, and I will get you all a link to that sort of thing. But let me hit the stop on that, not just so you can see my face, but I'm going to jump over here to my Chrome windows and have my perpetual complaint that Zoom tries to put its controls in my way for this. So I am actually going to show you another tool that's called CalcPlot 3D. So, and I'll give you all a link to that as well. But for this, if you wanted to take a look at something like what we did a minute ago there, 0.2x plus 0.3y, okay? if you look there, you'll see that it gives you room to specify where your X values should go and where your Y values should go, and then a number of grid lines. You don't want the number of grid lines to be too terribly large, but maybe 30 might make it look a little chunky. So I'm going to put it up to 50. Now, if you notice, it did not draw my picture here. As a matter of fact, it eliminated my picture. So I'm going to take and turn it off and turn it back on and have no idea why it's not working. Is 30 a magic number? Is that what happened there? And I haven't a clue what just went wrong there. X squared plus y squared. Turn it off, turn it back on, yay, and then it plotted. Okay, so I have not a clue as to why that would not plot the plane that we were talking about. Here you can see though that I can actually grab this graph and rotate it around a little bit and see what's going on with it. That's that parabola, or that paraboloid we saw before. If I just say, let's do x squared, oops, y squared, I guess. And the website's behavior actually has changed a little bit from the last time I was dealing with it. All right. Scrolling up and down is allowing me to zoom in and out, and I can rotate around to see this from different viewpoints. Okay. It has some nice options in here that are going to come up for you later on. Talking about vector fields is something that you'll want to be able to do in Calc 4. And implicit surfaces and parametric surfaces are something we'll look at later on. So for all we're doing right now, though, we're just really wanting to be able to plot surfaces in there. The nice thing that I just illustrated here is that you can have more than one surface, and you can turn one of them off, turn it back on, off and on, and that allows you to that kind of helps you with some of the visualization of seeing where surfaces interact or intersect at and stuff. Okay, so CalcPlot 3D, quick thing to do there. All right, this is Desmos. Most of y'all know how to interact with Desmos for 2D stuff, but this is for 3D stuff. I found it by quite literally typing into a internet search engine, Desmos 3D plot. And so it got me this, which I can move around a little bit there, but the function that it has is a cosine of xy plus t, and it has this slider on it where you can change the t value and get different stuff in there. Okay, but Desmos, you're having to tell it a g of xy, and it sets up a function from there. I honestly don't know what settings, I don't know what setting stuff had to be set up to get this to work in Desmos. I'm used to it just being a 2D plotting program. But, you know, we could probably work our way around that by just jumping over here to desmos.com, tell to plot. Let's see what happens if we just say f of xy equal x squared plus y squared. And it does not automatically plot it. So that suggests there was something special about the setup that we did in this. So I will send you all a link to this. I don't know what's being done differently in it to get it to be doing a 3D plotter. So maybe, yep. That. So in any case, if you're a big fan of Desmos, feel free to make use of it there. Okay. So I'm going to stop share again because the next thing I'm going to share with y'all is something that is peculiar to a Mac. And that is a program that's called Grapher. If you know Grapher on Macs, it's actually a super convenient program to be able to do stuff with. So, however, in order to get into it, I have to search Grapher, and then it starts a window. And then let me share screen here to share Grapher. And so you can see that it has 2D and 3D graphs. I'm going to tell it to do a 3D graph and leave it on the default. Tell it to choose that. And so you can hopefully see that it has the axes there with the X and Y and Z. And then I can tell it 0.2x minus 0.3y and hit enter, and it will graph a plane for me. Similarly, I can tell it to graph x squared, and I don't like the shading that it puts to it, but anyway, it does what I want, and it can even, whoa, even graph that there. Again, I don't really like the lighting that's taking place on this. A super convenient thing about it, though, is that once you've got that, I've hovered my mouse. I'm assuming it shows on the shared screen, but there's an option that says copy as and TIFF, PDF, and EPS. I'm going to say copy that as a PDF. And now, after I've copied that, if I've got something like Microsoft Word or something else open, I can just paste that right into it. And then later, for a document, I can tell it to print to PDF or whatever so that I could turn it in as part of the homework. So in any case, Grapher is an option that's open to all if you happen to be using a Macintosh. If you're not using a Macintosh, it's not there. There doesn't seem to be a Windows equivalent. I would not be surprised if Windows 10, somebody comes along and does that. So, all right. So then I wanted to try to show you a little bit of graphing these 3D functions using Colab, or if you have a different installation of Python. Again, Don will have a much superior version of this, but I want to show you a little bit the basics and a little bit the notion of how I find out how to do this stuff. Okay, so I'm going to share screen here and go over to Chrome. And here, the document that I have is in Google Colab. Hopefully, all y'all have dealt with that just a little bit by now. And I'm stealing some of what I'm doing from Don. So, but I want us to see how we get around to producing little graphs like this here and this here. So we're trying to do a surface plot, and we're going to try to do a contour plot. Okay. So if you look at this surface plot here, and I can zoom in a little bit to it, you can see that this is that x squared plus y squared that we've looked at before. It doesn't kind of cut it in exactly the same way though. So now zoom out, come on. Oh, come on. Okay, so if you take a look here, this is dealing with the same plot, but what it's doing is to just take it at different z levels and cut through it and see that you've got circles. So what I want us to see is how to tackle getting any of this to actually work. So I'm going to go ahead here and add some code, add a code block. And I want to try to show you how to figure all this stuff out from scratch. So the first thing is that we are going to have to use lots of things from a package, from a package called numpy, or as everybody who's in the know says, numpy. I always just refer to it as numpy though. And what we're going to use, and I see that I've actually run longer on time than I intended already. Okay, apologies. I am not going to do this live after all. All right. I'm going to just show you a quick things here. Numpy is a package that does numerical Python stuff. So I've gone ahead and imported that here. And whenever it comes up again, I will be talking about np dot something or another. Then I imported something called matplot.pyplot as PLT. That's just a standard plotting thing. This plotly stuff is something Don is going to do, and I'm going to delete it because I don't have that here. And pandas is a data frames thing. I'm also not doing, actually I'm not doing any of this. I'm just doing the bare bones basic plotting, okay? The first thing to see here is the x equals np.arange. And so arange is a way of setting up arrays. And here the lower limit I want to be minus pi, and the upper limit I want to be pi. And because pi is hidden inside of numpy, I have to say np.pi all the time. That seems like a pain, doesn't it? Let's fix that. Import, from numpy import pi. Now it knows about pi. And now I can just say pi instead of np.pi. Okay. And if you're spotting the fact that I dropped my minus signs, that was a good spot. Okay. But now the x's are going to go from minus pi to pi, and so are the y's, and they will go in steps of about 0.01, which means what I'm going to have like 314, 628 steps in each direction. Then this next bit here is something I tried to get around, and I don't see any way around it. I have to tell it new, that's a capital X, capital Y, which will be completely separate from lowercase x, lowercase y. I tell it to go to numpy and do something called a mesh grid. This is just going to take and make there be the ranges of x's and y's, and it makes them be independent. Okay. So then I went ahead and said my z variable was x squared plus y squared. If you're looking going, why is he typing star star? Python thinks star star means exponent. If you screw up and type the up caret, like most of us do, it will do something completely wrong. and there's no way around that. You just have to use their notation. So this next piece here is something I don't know a way around, and so it's just something you have to do every time. You have to say fig equal plt dot figure. That allows you to do certain options that we're not going to do. But if you don't say fig equals plot dot figure, then it just doesn't work, even though you don't want to change it. And then this ax equals plt dot axes projection equals 3D, you can figure out what that means. We're just going to plot something in 3D, so we need to have it be in 3D. All that is in order to make use of this function here, plot surface. And you have to tell it the x's and the y's and the z's. And that is why up above, we had to have the x's and y's and z's all defined out for us. So anyway, when you hit Command Enter on this, it plots it. So yay. If we wanted to come back on this and say sine, I have to say np.sine, unless I import sine. And then remember how that looked kind of ugly in that other setting before? And it's because there's so much wiggling going on. So if I go back here and say, maybe that I want to do it from pi over 3, negative pi over 3 to positive pi over 3. Then I'll get a little bit less of a section of it. And I kind of want more than that. So maybe pi over 2. All right. Yeah, so, and so you've got that little plot like that, right? Now, if you want to do a contour plot instead, I've already defined what my x and y and my z are. And so by just saying plt.contour xyz, I can get a view of what that looks like. And it's just, again, doing these levels where it's cutting off with a horizontal plane and getting a look at them. Okay, so how did I find out about those? I quite literally just did a Google search for, let's see, pie plot, contour plot example. So you want to include the word example in it, because if you don't include the word example, sometimes it just gives you, here's a plot with no code to show you how to do it. So, but that gets you started a little bit, all right? When we come to class and you're wanting to produce these plots, have the computer ready to go, have a collab session started up, and we'll work through things together. And that's just what we do on these, okay? It's not super rough, but you have to be willing to make a mistake and then figure out how to fix it. That's how you learn. And in particular, that's how you'll learn on these, because nobody ever gets them right the first time. Okay. All right. Come to class. We'll get it all figured out. It won't be easy, but it will be doable. All right. See you there.